we come to the main part. We want to build a new app. And yeah, okay, you have to do some things. It's not too complicated, but you have to take care of some things. So the first thing you do is you go in your, no, not here. You go in the app ordner, folder, sorry. So apps, GPU apps, and take one, so I would suggest it, take one of the apps that works and go from there. So for example, you take this driven cavity. So it's the simplest one. And I simply do copy paste, so the whole folder, and then you have to give a name. And so I'm not a really creative guy, so I call this somehow workshop app. Yeah. Maybe you have a better name for your app. So give it a name, and then you have also to change the data in it. So you have here a CPP file, give it a new name. This is maybe something which is, so needs some minutes until you finish it. Maybe also change this config files here. Yeah, so this is the right naming. And also you have to go into the CMake list. Maybe I can put it here. Okay. Because here the project name is defined. So how you see it in your Visual Studio Code. Yeah, this is separated from the file name. So this project is called now workshop app. Okay. Then save this thing. So then you have all your files here fixed, but it's not everything. You have to go back in the folder up here and go into this GPU CMake file. So we, what do we miss? What?
I can't see which folder you're in right now.
Yeah, sorry. This is I'm in the upmost folder. So I call it VirtualFluids, where you can go to apps to build the root folder. So where you check out your project, this folder.
So the apps folder?
No, up level 0, so to speak.
Okay.
And there are config files, no, not config files, CMake files. And one of them is called GPU. Can I make this? No, it doesn't get bigger. Can you read it better here? No. I don't know how to scale this here.
So it's the CMake file,
GPU.cmake, right. So we can also put it here. Yeah, I don't need this. Okay, and here we have to do two things. First, we append this user app here. You see, you have some included here, driven cavity and all this stuff. So here we add this workshop app, and we add a subdirectory also GPU. Okay. This is what you have to do in the first place. So we see there will be something else, but what you need to CMake with your new app, this is what you have to do. So and what you have to do is to run again CMake. Now, if you have changed everything, then call. Oh, here it was. So CMake again. Yeah.
the CUDA library. I don't know, is it necessary to choose this, or why didn't you choose it?
Where do you choose the CUDA library?
I think it was online as one of the options. I don't remember the command. 1 second.
When you, maybe I don't get it, but
So in the, I think in the online setup, yeah, there's a line where you choose the CUDA version,
It's called
and
PC
and
Make.
this is actually something that in Chennai we had some problems with too, so we had to delete this line.
yeah, so this you can leave it out.
Potentially you have to leave it out because when your version does not match the version that is given there, then you may run into problems.
So in this Docker container, he simply ignores this. I get a warning, I ignore what you have written there and take 5.2.
Because I thought like it's essential so that the GPU can be run optimally.
So the optimal way what you can do, in my opinion, you go to the CMake folder here, to CMake config files, and build a new config file for your machine, and therein you define the right compute capability for your machine.
Hard-coded.
No, you always search for this config file. If you don't have one, he set it to 5.2. If you have one, he set it to the right version. So you have to do it once for your machine. Maybe you change your graphic cards every 5 weeks. I don't know. You have the newest one, I know. But if not, then you change it once. So I have it, for example, for, I don't know, here Moloch is one of the computers I use, and there I have this CUDA architecture once defined, and never think about it again for this computer.
And how is it linked? Because now there's just a file where you write it down. Oh, it's because Moloch is now linked to 86.
Moloch is the name of the computer. You name this config file the same way your computer is called, and then it works.
And Moloch is the...
It's my computer. It's one of my computers in the office.
But that's an alias that you gave?
Yeah.
Okay.
We call everything Lord of the Rings style.
Nice.
Not everything. Not Martin is the exception. Not you, but everyone else have some Lord of the Rings names for his computers.
Sure.
Yeah, sure. You know, some nerdy stuff, you know. Okay. So CMake now works, but we have to look into our app again. There are some things that are not changed, I know. But we found now here this workshop app. This is new now. You see it here? And we open up the CPP. And wait.
You should change the name of the author and the name of the in the beginning. Yeah, you should just.
Yeah, if it's your own app, change this name here.
And auto group, maybe driven cavity.
And this thing also. So I don't have to change the author because I'm the guy who's sitting here, but yes, this you should change. And also this, so if you want to write it out somehow, it should call it the name you want to give your app. Ah, damn it. Not copy, I want to paste here, zip. Maybe this way. And you also have to take care that you're now taking the right config file. So you just have the old path here. So you have to also change this. As it goes to the right folder, takes the right config file. This is you have to change. And something I forgot when I tested this. You also have to change this here. So because the output path is overwritten from the one in your config file, so you have to change this path here. and I guess also here, also here. So now I guess you have changed all the paths and names. Now we can try to make and then afterwards to run it, and then it should work. Should. That's right, it should work.
So what are we going to, what example are we going to do?
So now we can do everything with this app.
Yeah.
So we can change the boundary condition, for example, and yeah, change the flow. Because now it's a stupid driven cavity. So, but when it runs, then okay, I'm open for ideas. Yeah,
So what do you want to see?
depends on how long you want to work here today. We can just do a channel flow. A what?
It's similar to the atmospheric boundary layer in many ways, maybe we can explain.
Yeah, just a channel flow. We can do it. Yeah.
What
So-
about restarts?
Hmm?
What about restarts from?
Do we have restarts here?
So basically, we can do restarts, but I'm not sure that we have included it in an open source code. So I have to look. Okay, let's see. Okay, something. So yeah, of course. TLIP. That's the point. Okay.
No, I'm thinking like if we are going to do a channel flow, are we going to put the inlet as a pressure?
No, I would put a velocity boundary condition as an inlet.
Because we was talking about like
What about like a pressure driven?
yeah, pressure.
Pressure driven. Oh, okay.
Yeah,
Yeah, we can try it.
we can put the top like as like a no sleep. Top is a sleep and then down is no sleep.
It's a strange channel, but
Yeah,
yeah.
yeah.
Okay.
Top is slip, bottom is no slip, and why?
Pressure.
But what do you want to
Those are
decide? Do you
periodic.
want to have periodic?
Yeah.
Yeah, okay.
Then
Per-
it's gonna become very
Periodic in Y, in Z, no slip, and pressure.
No.
pressure. This goes out, just breaks out. and
Okay,
goes,
so that's actually not a channel, but you would have a plate and
Yeah.
a plate on the bottom.
mm,
And you would have atmosphere at the
Yeah,
at the
yeah,
top,
at the
and then okay,
periodic. Yeah.
and then periodic.
It's like a half channel.
Yeah.
Okay. Okay. Let's have a look if
And then we put
we start from something that works.
Some cube on
Yeah.
and then we see. Okay,
Yeah. That's cool.
that would be fun.
That would be fun if it works. Yes.
Or a small cylinder.
Yeah. Yeah.
Yeah.
Okay, so you see, when you change all the names right, then you build the right folder here. Okay, but this is still not a half channel. I guess no. -1 should be show it. Yeah. Apply. Okay, so good. Okay, we start from a working app. Okay, before we destroy everything. Great. So what we want to change? Maybe we make it a little bit longer, right?
Or we could start with the boundary conditions and then make it longer.
Okay, start with the boundary conditions. So here we have no slip everywhere instead of the top.
Yeah, but on the top now we do slip.
We now do a slip. And I guess we don't need anything for your slip. Right?
Doesn't slip need a normal?
No, I don't think so. I guess it works this way, huh? This should be
The y out would be 0.
Okay, so when we set a slip boundary condition, what we need to define a normal. Yeah, so the direction to which we have no flow and then perpendicular to this. I mean, like we would, so there's zero velocity in that particular direction, which is the normal, and the other way is the other is free.
so in y direction you want periodic, right?
Yeah.
Okay, then we can leave this out here and have to say a true here. Yeah, periodic in y and leave it out. So and in plus x you want outflow.
You would your pressure boundary condition, higher pressure in the front and lower pressure in the end.
Okay, then I understand it wrong. Okay.
The outside could be just non-reflective going down.
Outside could be
Do nothing.
but no, I mean then you need to have a velocity in the, because otherwise you would just go to the certain pressure, because the outflow does not set the pressure.
Yeah, true.
I mean, so this is, we can do this way, but what do you want? You want pressure.
Pressure.
So why don't you do periodic?
Then how does it move?
You set a pressure.
You mean you want to
You
set a force?
You set a constant force for the entire domain.
Constant forcing. Do we have this?
Yes.
Okay. So no periodic.
It's getting more
Periodic in x and y.
In x and y periodic.
X and y.
Okay.
And then no slip at minus z.
Okay, so maybe you should talk before. He said something different, so I don't know who's. Okay, I don't. Okay.
I mean, you can do it in the end, however you like.
No, how Henry like it. Okay, so periodic in x and y. In that direction, slip on top. Yeah, plus z minus z, no slip, right?
Yes.
Okay.
With the normal, so that's basically outward pointing or inward pointing.
That doesn't matter
Okay.
because it's 0. We multiply by 0, so it doesn't matter.
Ah, okay.
Yeah.
Yes.
So slip. So slip. Basic slip. In para. Para. Oh, okay. I like Visual Studio. Set forcing. So in that direction. No, x. Okay, how I have no feeling what's the right forcing here. I guess something 10 to the minus 6 or so, no?
I mean, then this could go, you know, you're adding up.
Too much, yeah.
Yeah, so this will go to.
I guess something like that.
Well, it's difficult to get a feel because this has to be trained only through the bottom. Yeah. So we'll see how this ends up.
So in Basel we have something like 1 to the minus 6, I guess, when I remember correctly. Maybe this is too high here, but we will see. Expected, yes, you're totally right. Okay. So, do I miss something? Probably I missed something. Slip. No slip bound. No, this is the wrong. Which no slip boundary condition we want to use?
On the bottom.
On the bottom.
So,
Delay, bounce back, interpolated, compressible.
actually, here we don't need any interpolation, right? So we could just use the normal bounce back.
Okay. Totally have the feeling that I'm missing something, but okay, we will see.
Do we have a paper plane here so that we can put it?
No, we should add the paper plane as an app.
Because now making it completely cool is we put something thin in and use the thin wall boundary condition.
Yeah, that would be
as an
nice.
object.
In the channel.
In the channel,
Yep.
yeah. Do we have some things? So can we?
You know, I'm not able to use this SDL file. I have to fix this. Okay, so he wants me. What is?
So the velocity.
Ah, okay. We did.
Yes, so we don't set the velocity anymore.
We don't need it anymore.
Yes.
So we can leave this out. And they are, but they are used somewhere, I guess. Where do I calculate this? Yeah.
We need from that velocity we compute the Reynolds number for this plane, yeah, I guess.
Okay, we got it here. Okay. That's just a warning, right? Let's see. Okay. Velocity boundary condition.
Okay, so larger than the viscosity is too high.
Yeah, but also the velocity boundary, I don't see the velocity boundary condition.
There should not be any, right?
Yeah, but was not set.
And search for velocity. Find velocity.
don't get it. The boundary condition.
I think, if I remember correctly, I think that's just a bug.
This is a
It
bug.
wants to the boundary condition factory wants a velocity VC, but you don't need it. It's not going to call it.
Okay, so this is
needs a velocity boundary condition set.
who implemented this crap here. You can do something like that. Okay, but don't look what I'm doing here.
It's all on the recording.
It's all on the recording, yeah. Yes.
Do we have a velocity boundary condition?
No.
I think he is now doing something that you should not.
You don't need to set a velocity boundary condition in the grid builder, you just need to set one in the VC factory. Otherwise, it just throws an error.
Okay, this is more confusing, I guess. But okay, whatever. Okay, what is the reason we want a velocity boundary condition?
You asked not to use a velocity boundary condition. Most of the time we have a velocity boundary condition. Now, you always get.
Yeah.
I mean, it looks like you always get to the bad point, but there's so many bad points in this that it's easy to hit it. Yeah.
We just did it.
Sometimes we think you know the code too good. You exactly know where you have to go to find the problem. Okay. Okay, not. We need a velocity boundary condition. Okay, it's interesting.
So now, what was the solution? That you put the bottom to velocity and set velocity to 0, or was this?
Yeah, so he take a no-slip boundary condition as a velocity boundary condition. You also can set this here to velocity and says you have a velocity of 0. It's the same thing. So a no-slip is a velocity with 0 velocity. So let's reload this stuff here. Reload files. Okay, find new files. This doesn't work well. I don't see anything. Oh. This is too high. Probably. I guess this is too high. The forcing is maybe it's growing.
Because it's growing.
But maybe it's growing too fast. Yeah? Oh.
No, not yet.
1.6, wait, 1.9, okay, it's growing fast.
Or is this actually in lattice units?
No. I'm not allowed to write out lattice units, you know.
So then what value is this?
This is, okay, we can look what we said in the beginning. Velocity is 1. And LB is, okay, we don't care. But, yeah, this is the relation, right? The ratio is 1 over 0.05, right? 1 over 0.05. So something like...
Okay, we can change this later, but can we...
So I can, okay, a really bad hack. Don't look what I'm doing here. I can do something like that.
The conversion.
Yes, so he's setting the conversion factor to 1, so we get it in lattice units. Yeah?
But okay, maybe this is the idea. Play a little bit with this thing and look where it's crashed.
So Now, can we put something on the bottom, like a cut-off cylinder or something?
A cut-off cylinder.
We have a primitive cylinder, or
Yeah.
or like a half sphere sitting on the ground. I don't know, something like this.
Yeah, so we can steal it from here. Wait. Oh, I was too fast again. No. No. Here. What? Maybe we steal everything. Bum, 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 bum.
So we are now introducing some geometry.
We have to put it after the grid, after the coarse grid, right? So here. Maybe we put it in here. So leave this out. It doesn't work right now. So, and you want to put it on. Ah, okay. I miss the include.
We have to add a header for this.
Yes, grid generator sphere here you need.
So there are some primitives, yeah, like cylinder.
So cubed is always in it, but okay, we want a sphere. So okay, I don't know what is this. Okay.
So we can set.
You want to put it on the ground. So where's our ground? It's at minus 0. No, it's wrong. Wait, here 0.5 times length in that direction. Zip. Zip. So and
something related to length. Say length times 0.2 or something.
two.
Yeah.
Okay. Make. Yeah, it's in the middle. And X and Y in the middle and Z on the floor.
Just gonna cut it itself. There's half of it itself.
You only discretize the upper part, so the rest
did
you ignore.
we already introduce it as a boundary condition?
No. This is missing. You're totally right. Yeah, so you always forget something.
Yeah. And here we now use interpolation because we have a perfect boundary.
Yeah, so you need this, that I explained, this geometry boundary condition here. And this is a velocity boundary condition. With no velocity, so it's a no-slip boundary condition. Zip, zip, zip.
Is an interpolation boundary condition?
Yes.
Type geometry, how do I see this?
It's under.
No, when we first put it,
Oh, we have to.
then we change.
Okay, then we have to do it both. Can
No,
we?
we set a new one.
But could we have
The bottom is
still no slip.
The button is still the usual no slip without interpolation, and now we set a new one with interpolation, right?
Yes.
Here, yeah.
That's a stupid question. Could we not like make no slip directly on the geometry? We have to impose a velocity. There's gonna be no slip on the velocity on the sphere.
Yeah, it's,
Yeah, so he adds a new boundary condition.
Yeah, but why don't we put like set no slip boundary condition on the geometry instead of setting like a velocity and setting to 0?
this also can be done.
Okay.
Let's do it that way.
So then no slip, and then you have to leave out these values here because then it's clear at 0. Okay, and then BC factory set no slip boundary condition, no slip. Wait, something missing. No slip BC, and you want interpolated compressible, right?
It is what we said. If we don't
Okay.
do
Okay.
Hmm.
Wait. Yeah, okay. Let's save and look if it works. Maybe we should have started with implicit bounce back. Make it step by step, but okay, we can try to do everything in once.
So how do you now know which boundary, like of the 3 lines 152 to 154, which line applies to which boundary?
So yes, you are right. So we have this is, yeah, should be
No, it's
So it's this thing zero that we did?
no, it's just you can always only call one kind of velocity boundary condition. You can the entire code just on all boundaries that are marked as velocity. It's only one kind of velocity.
You cannot have two.
You cannot have two you
Yeah,
cannot have two
bounce
different
back.
kinds
Okay.
of velocity boundary conditions.
Okay.
So all the slip ones are gonna be slip compressible, and all the no slip is gonna be no slip
No, I
interpolation.
think this is not true. You could have slip in different directions.
Yeah.
So by
But it's always the same kind of boundary condition.
Okay, so the same type of algorithm that we're using.
Yeah, so right now it's not, so I guess you cannot distinguish between this guy and that guy.
Yeah, okay.
Yeah.
And also not the top and the bottom or anything like that. It's always going to be the same sort.
Now all of them are gonna be interpolated, no slip.
Everything that's marked no slip uses the same no slip.
Okay,
Which is interpolated.
okay, okay.
So now we define a velocity and it's not used.
Yeah, the velocity just
But Henry said to do it.
that's the code.
End of error message.
Now
End of
try to
error.
get-
No, now we have to done something stupid here. Ooh. Size of geometry, okay. So maybe I've done something wrong with the geometry. 0.1 is maybe too large. What is, maybe we don't understand what length is. Okay, length is the whole length. Ah, okay.
But this is why I thought that 0.2
Is this too much? It should work.
maybe 0.02.
Yeah, maybe it's too large. Okay.
So in X and Y, it's on 0 and 0. So you have the sphere.
It's outside.
This half outside, yes, but it's periodic in that direction, so it goes into where no sphere is.
Yeah, so it's like
The sphere is.
No, I said that. Wait, is it in Z? It should go. It should cut through Z.
Yeah.
Like that. Okay. No,
In X and Y, it's in the middle, and when it's not too large, it should work. And when you go through the periodic boundary conditions, then probably this is a problem.
I didn't see that you said the course grid starting at minus X, minus 1/2.
Yeah.
Yeah.
So when we put it in the middle, it should work.
Give it a try.
No.
Okay, so that's the interesting part when it doesn't work, right? Segmentation for geometry.
Okay, let's put it in the middle. Okay, I want to see if it works. Maybe.
yeah.
Actually, did it run? No, it did not start running, right? So it
Yeah,
was
yeah, right.
switching right there, yes.
No, it's yeah.
Because otherwise we could look at the zero at the time step 0 output.
Yeah, but we don't get one.
See, this is real world. It never runs the first time.
No, never.
And the second time either.
Oh no. What is wrong with this sphere?
Nice geometry level. Geometry level. So if we remove this, fit build the edge geometry, then it should work, right?
When we remove.
The geometry, edge geometry.
Yeah, but okay. We don't have the sphere.
Yes, but check it anyway. If you don't have any other idea, make it, you know, always, okay, so what I always tell them is you have to think like interval, you know, if you have this problem, try to corner it. So you know where it crashes, and you have to go on the other side to a version where it does not crash, and then try to contract it. Yeah, always watch crash, no crash. Yeah, and then shrink it.
I can, yeah.
Change it.
So let's run it.
No.
Oh,
Ah.
okay. Then it's because then it's something else.
Okay.
Where?
We are adding geometry. How does then we put the boundary condition on it, and then we say it's geometry. Like how does it know which geometry is what geometry? When we put the boundary condition.
It's also all geometry.
Okay. So okay. We say it's okay. It's like
Thank you. Okay. Aber wir müssen jetzt dieses Problem lösen. Wir müssen das Problem hier lösen.
Yeah, this linking is really slow. I don't know why. Yeah, so this that we have multiple boundary conditions here, but only want to use one of it is a problem. So this is simply wrong what we are writing here. So we have to decide to use only one. So now it should work. No, we put it out. So okay, then we can put it back in. We start in the middle. So I always, okay. Sometimes it's better to do things step by step. Yeah, not everything in the same time. When you search at the wrong place where the bug is. As Sören would say, small commits, always small commits. Yeah, and we learned a lot from Sören. Yeah, Sören was a clever guy. So. Oh, he is still a clever guy, but he's not here anymore.
This is because this is why he is now earning a lot of money. Yeah?
Yes. I guess we cannot put this on YouTube. When he hear it, he comes to us and hit us. No.
No.
Interesting. Das is interesting. Geometry values on level 0. Segmentation forward. Interesting. Okay. Wait, do we do something differently with the boundary conditions here? No. Okay, I try one thing. Just to see. Okay. So, consistency. Still too large? No. Cannot be too large. So you want to distinguish between this boundary condition on the surface of the sphere and on the side, then you have to define one as no slip and the other as velocity, I guess. Then you can distinguish between these two things. Yeah, okay. So you have to define this at velocity if you want to use a velocity here. So you cannot write here no slip and here velocity. This doesn't work. It have to fit.
Don't combine.
Yeah, don't try to combine no slip here and the velocity here. So you have to have velocity up there and down there.
The grid builder needs the same like the
Yeah,
PC factory.
the grid factory and the PC factory have to have the same boundary conditions. Okay. Now.
So it's pretty small now.
And it's so this is
Maybe make it a little larger and put it to on the bottom.
okay. What step by step?
Okay.
Larger or to the bottom? What's the first thing? Larger. Okay.
Larger.
We start with making it larger. So
we said that it's
am I right here?
0.2 of the
where I'm lost here. Wait, build grids, add geometry. Here we are.
Or, oh, danke schön.
0 point.
It's so always it looks like
Yeah, it's so coarse. So maybe we can add some points to the. Damn it. To the grid too. So this is a pretty coarse grid, and in addition a really small sphere. And I guess this is still okay. Yeah. Maybe I can change this here back to something like that. Oh no. In this direction, right? Okay. Aber die Kugel ist noch sehr klein. Wir machen gleich nochmal eine größere hier. Okay. Okay. Now you can imagine that this is a sphere. No, periodic boundary conditions, you see? Okay. Now put it to the ground. Okay. Here, right? I steal it again. Copy and paste programming. And see, this is. Make.
Now it has some room.
The issue was the boundary condition.
Yeah, that we define no slip, but want to use velocity. You have to define both to velocity.
Oh, okay.
Yeah.
The grids,
The grid has to be the same than a factory. Yeah, the grid builder and boundary factory,
maybe
they have to fit together.
You should take this to explain what is the role of the grid builder and the boundary.
The grid builder defines which nodes are boundary nodes, and the BC factory defines which style of boundary condition you want to use.
Okay.
And these two things have to fit.
And so you remove this no slip boundary condition.
Yeah, I changed no slip to velocity here. Okay.
Yeah, so velocity can also be interpreted.
So now it's down there, as you wish.
Oh, wait. It's a hill.
Yeah.
It's a complex terrain.
That's actually pretty much what I'm interested in. So if we could share that.
Yeah. So
Yeah.
can we actually do
Now
a refinement that is cutting into this boundary?
we can try. Yeah, I guess we steal it from here.
We always steal it. We never.
So this is what every programmer do. He said, okay, I have done it once,
Yes.
and don't try to.
Everything that has ever been. So this is like everything has already been done.
So
You know what? We could have created a branch and called it workshop and share it with the
yeah, so I can send you this app.
for Amy, copy and paste.
Yeah. So wait. So I try to concentrate. Yeah, geometry here. So here we have something that we find. So yeah, instead of this thing, take this one. And we have to, so now we start to like have a variable for this, right? Ah, okay, we don't care, I see. So, because it's all the same here.
So, yes, we put it to the same location, obviously.
And say 2 grid levels, right?
So, do we need to make it a little larger, or is this the same?
Maybe it's a good idea to make it a little bit larger. Maybe it's not enough
Not in the
space.
same step. First check. No. Or
Yeah, maybe it crashes because we don't have enough space for 2 grid levels in our domain. The domain is too small.
Or we
You can
may,
just put one.
You can try one. Yeah, you're right. We can try. But okay, maybe it's crashed. We will see.
or we make both smaller than 0.1. Okay, but let's try it.
We should use the same size as
Yes,
our
yes,
spheres.
both of them, yes.
Yeah,
Okay.
right. So, I don't know. Save first.
Build second.
Build second. So maybe these are changes you cannot do in your config file too easily, I guess. You can try to get maybe the size of your sphere and maybe the position. Yeah, but you cannot say, okay, refine in this way or that way. Probably. We have to, yeah, you're totally right. Now it's on. Semicolon, yeah. I teach too much of this Python stuff, you know. I forget. Python is evil. Okay, on Friday we talk about Python, I guess. Right? You say something about Python, right? Yeah. Python is evil. I teach too much of this Python stuff, so I forgot these semicolons here. Linking. Oh, seems to work. I don't know if I have to reload it. I guess I have to. I guess this is only. Wait, wireframe? No, just work. Oh, this is too easy.
No, there's one.
There's one refinement level here.
Maybe 2 would work.
Maybe 2 would work, yeah? Should we try 2? Okay, we can try 2. Refine. Okay, it's 2 word here. 2 level. I'm so stupid. Yeah, yes, okay. You don't have to do it with Python, you know. Okay, you're the boss. Can I teach C++ in the future instead of Python?
This depends on how much they go on, the others go on my nerves.
Yeah, so I'm teaching for the second semester civil engineers Python program, also beginner course of programming with Python. And I always switch between these things, and so at one point you get confused. Okay, I guess we have a little bit high viscosity on the second level. Yeah, I got a warning.
Maybe we should make the viscosity much smaller.
Yeah, this is a good idea. But first, have a look. Before we change something, bam, two good levels. Much smaller,
Much smaller.
10 times
Like
smaller.
1,000 times?
1,000 times. What is the value? Okay, I don't look. What is 1,000 times smaller?
Yeah.
The viscosity. Okay, so the easiest thing to
Just make the Reynolds number.
make the Reynolds number higher. 1, 2, 3, right?
Yes.
Okay.
It's gonna be not too long. It's not gonna change the time.
No. We just changed. So maybe I make it. You can see you use the Reynolds number.
I mean, you can potentially run more times, but
Yeah, it's now only 10,000, right?
yeah.
Should I run more? Okay.
Yeah, true.
Maybe we do it this way. Okay? Then we have the small Reynolds number in the beginning and the high Reynolds number in the end.
Okay.
We can compare.
It's very confusing. Then.
Yeah, it's totally confusing. Yeah, this is my style.
You know, you're not teaching to confuse.
Not? So then,
You have to compile it again, unfortunately.
yeah, you know, it's the ape would learn it at a third time, I guess. Yeah, this linking needs a lot of time. I'm pretty sure that when you don't use Docker, don't need so much time.
Docker only has.
No, I guess this is the difference in the compilers. I guess the MVCC. Yeah, sorry. It's faster in linking compared to the GCC. So I guess this is,
So you
yeah.
see, even though you tell it 10 times the times, but it's not much slower because actually what is the expensive stuff is.
So you see here it started, but now I have to load new files, right? For example, right now I can reload files. Yeah, turbulence. Oh yeah, do we want to rescale it? Bam. Oh, I see something up here. There's my surface. Wow.
Look at this, like atmospheric boundary, like.
This is nice. This is nice. So how far we got here? So what get I? Yeah, 1.3 or 1.4 giganoops. It's not too bad for a laptop, I guess. Oh, it's okay. And Docker. Laptop and Docker. Still performs well. So this was wrong. So reload the rest. Oh, it's broken. Oh no.
No, because maybe the velocity is getting too large because we have this force.
The force is too high, right?
Yeah,
So what is the force?
Faster so there is no limit because we're adding force. Yeah.
We now have lattice Boltzmann velocity here, right?
So what? Yes, you see.
Wow.
You see the velocity is
Oh.
1.5.
It's still not breaking down.
Yeah, it's 1.5 in lattice velocity.
No, it's 15.
Yeah, 15.
15.
It should be much
Oh,
earlier.
it should be dead already, right?
Oh, it should, long time ago it should be dead. Okay, so this forcing is much too high. So make this forcing. Where is here? Here. Okay, I need more zeros here. So maybe.
Okay, but still, I mean, since we have almost nothing in the way of it, so it will keep growing and it will crash. Yeah.
50.
How do you explain this?
So it's your great method. So this is.
Yeah, but there's a CFL condition.
Exactly,
You know,
yeah.
then
You have you have the speed of sound, you cannot break it.
You see that we can.
You broke it.
Yeah, I broke it.
That's almost the speed of
I don't care about speed of sound. Break everything here.
I don't understand. Are you sure this is not TUBS-IRMB?
So we
scaling to one.
we put it to 1. Velocity and velocity AB both are 1. So what I said here, the relation between these two, this ratio, is 1. So when I write something out, it's the same as the lattice Boltzmann unit. Because you just take the velocity you have in your lattice Boltzmann and multiply it with 1. So this is lattice Boltzmann velocity. It's crazy, right? Okay. So now it's getting slower. Yeah. But 0.6, okay, it's 10 times, yes, it works. 10 times slower. Okay, maybe we have to add another 0. It's crazy, right? Oh, yeah, no, it's broken. Or I'm getting too far, I don't know. Yeah, no, it's broke. It's broke. Okay, maybe.
Yes, so it's yeah.
It's like going towards
No, this makes sounds
Yeah,
here.
but that's two. I don't know what they with my gates down transfer.
You build Docker and now Docker is running all the time. Voila.
Turn this off.
Okay, so it's nearly 6 o'clock. I don't know when we want to stop. So this is fun and all, but I don't know when we want to stop.
Is there anything that you want to add the simulation? So we did not unfortunately see symbol boundary.
No. So maybe you also have no app where you use the thin wall boundary condition, right? Do you have an app where you use the thin wall bound? Do you use it in one of these provided apps? No. Okay, so we need an additional app, but I write it down, right? App, yeah, paper plane, right. We need an app.
Probably not now.
Not now.
Okay, I can fold the paper plane for you.
Is this going down? Ah, here, okay. 0.1. It's still pretty high here. Pretty high.
Okay.
So maybe we passed the limit.
I mean, if you could show the Q criteria on this.
What do you have to do for this?
So first you have to build a vector.
So
The
times
velocity components times the vectors
circ times
times the unit vectors.
times so
Apply,
bam.
and then you go to the filters, compute derivatives,
Dip.
and then you have to go on
This is
the
right.
velocity and then vector gradient. I think
What?
probably you have to press on the this Zahnrad.
Nee, warte, hier unten. Oh, you get this.
Where's the input? Compute.
The input scalars and vectors here, and output is vorticity.
Is the wrong version? Should we have a different filter?
It's 5.13. I don't know. It's pretty new, I guess.
Why don't we see Q criterion here? Why don't we see the Q criterion? Or is this a different filter? Yes.
You have to turn it on.
Yes. By
I mean,
Where?
there is a filter called the gradients configuration.
I don't know whether
Try
that.
to go to filters. No, for Q criterion there is another filter, I guess. Can you go to calculator? I mean, you should not have deleted it, but anyway. Wait a minute. The gradient. Search for G gradients.
For G, here G, generate Gaussian,
Apparently it's
generate.
Compute
Computer.
No, here, wait, there's a gradient here. There's a gradient there.
Exactly, gradient.
Gradient up.
Now there is a Q criterion down there. You see it. Q criterion array name Q. Yeah. You don't want to. Yeah. Then apply.
Not not geo. Not geo. You have to go to.
Velocity.
No, you just have to put it to define the one.
Yeah, and
Then
then
you have to
slice.
slice.
No, not slice.
Contour.
Yeah, contour.
Exactly, contour. You have to pick one contour. I don't know. Zero maybe.
No, not zero. Say 10.
Okay. You can take silver. I mean, you can pick different contour to see different.
So there's a vortex in the.
These are vortices.
Okay.
It's not symmetric.
No.
Nice. Pick another. Pick another contour, maybe 100 or something.
100
Less.
less. 100 less.
I mean, okay, I can try all of them.
Okay. Yeah. When you take, then you see more vortices, right? And you make it smaller.
Okay.
Make it larger, you will see fewer.
See this.
So yeah, right. So you just see this. That's what is the horseshoe vortex in front of the sphere. Yeah. And you actually see this how it's turning. Yeah. Yeah. So this is the vortex in front of the object.
Yeah. Do we want to stop here?
Maybe we stop here, Martin.
Thanks.